Hello everyone. So in this video we will talk about LRU with linked hash map. Okay, that's the internal collection available, so we will use that, and it also has a time complexity of O of 1 for get and add operations. Okay, last video we saw LRU with hash map and double linked list, and before that we saw hash map and linked list for LRU creation. Okay, so first one was O of n time complexity, and this hash map and double linked list was O of 1, and in this linked hash map it is also O of 1. Okay, so it's a straightforward, very easy, okay, collection framework using it. Let's just see. Okay, let's just go into the code. So yeah, I've already created a class called LRU linked hash map class. Okay, so in this I'll write the code to complete LRU cache. Okay, first of all, to use the linked hash map, right, so we have to extend that class. Okay, so let's extend that class. Okay, it's called linked hash map. Yeah, first one. Okay, uh, it required two types of inputs. Okay, so first one is key. So in key I'm putting as an integer. Okay, and second one requires a string. Okay, I'm taking it as a string. Okay, the thing is, like, yeah, I have to also tell my class that I will be getting string, sorry, integer. Okay, yep, that should be fine. Okay, yes. Now, to make LRU cache, first of all, we have like the concepts and all. You might be knowing that it has a capacity, and whichever data is get first, that will be updated in the order. And if new entry is coming up and my capacity is full, then I'll be deleting the most oldest entry which is not used, something like that. Okay. So firstly, for that we need a capacity. Okay, means the size. So I'll create one variable for that. Okay, so it will be final int capacity. Okay, yeah, so this will create. Now we will create our constructor. Okay, so in that we will take this value. Okay, so we will having int capacity as an input. We will assign, before assigning it, now we have to do one more thing with the setting up our linked hash map. Okay, we will be calling our super constructor. Okay, with the function super, and we will pass him the size of linked hash map that you want to create, the load factor, and the access order. I'll tell you that. So super function is here. So first parameter it takes is the capacity. That means how much size it should be of created. Okay, then it takes an input of load factor. Now what is load factor is like, if my linked hash map is full of this much amount, that means 0.7f, that means 75% is my hash map is full, then it will automatically double itself. Okay, so this is what it is. And the next is we will be adding true. Now the third of parameter it takes is like the access order. Okay, so you can click on the super and get to the complete actual class. You will see the same implementation. Okay, so access, see, the access order is also coming up. Okay, so this means whatever I want to, I want to make sure that my linked hash map comes in an order. Okay, so my order is maintained. This is what I'm aiming for. Okay, now we will also use the capacity. So we'll set our internal capacity. Okay, this is done now. Okay, now yeah, this is done. Now it's one more thing which we have to do for linked hash map. Okay, now we have to remove the oldest entries, right? So there's an already a function available inside the linked hash map. It's called remove eldest entry. Okay, I'll just show you to that. So see, this is the one. So we will override this function. Okay, and we will give our own functionality. Now linked hashmap wants to know if its size is full, what you want to do. Okay, means what it should be doing it. So I have to remove my eldest entry. It's like a true or false. Okay, so I'll return. Okay, I'll say return size. Now size is nothing but a hashmap function available, so directly I can call that if my size is greater than capacity. Okay, if my size is greater than capacity, I should remove my eldest entry. Okay, so this I've overridden it. If you go to the actual function of it, so there it will be definitely be returned as false, because by default it is false. Okay, so we are overriding it, and that's how we are writing. I'll just show to you that also. Okay, yep. And our function was basically remove test entry. Yes, let's find this out. Yeah, let me just go below. Yep, see over here. So remove test entry, it's automatically returning as false. Okay, so we have overridden this function. Okay, nice. So this is the all that you want to do. Okay, to setting up our LRU cache. See how small it is. Now we will write our main class where we will create objects and then we will check it how it's working. So I've already created a main class. Okay, let me write it inside. Then I've just created the class. Okay, let's start writing it out. So yeah, I'll create the object of my class. So it will be new. I have to provide the capacity. I'm making it as a 3. Okay, so I can hold uh, three you can say stacks or three variables or three whatever data I want to store up. Okay, so I'm thinking of making it as a 3. Okay, now let's start adding the data in that. So put option, because it's a hash map, I have extended it, so put option is available. I'm taking as an integer and a string, so I'll say this is one data. Okay, similarly I'll duplicate it and I'll make 3. Okay, I'm copy pasting it. Yep, now let's edit this. I'm just editing it. 3, and then this will become my 2, and here I'll change it to 2. Okay, now we will do the same operations like we did in our last two examples. Okay, so we will now first print out the my s. Okay, so I'll just say for one key. Okay, and then we will use now get operation. Okay, it's a hash map, so definitely get and put operations, that's what we have to use it. Okay, to add and to get data. Now this will make, I'm just writing it out, this will bring one key to first used. Okay, recent used, to be sure of. Okay, so this is how. Now we will write the next thing, like now we will try adding. Okay, so linked hashmap dot class dot put. Okay, we will now add 4. Okay, now I'll tell you what this will do. Like if you have seen my previous video, you will definitely be knowing what this will doing. Okay, this is for data. Okay, this will actually remove the second key. This will remove the second key. I'll tell you why. Because one has already become the recent used. Okay, now 2 is the one which is the oldest over here. Okay, let's see, first we added 1, then we added 2, then we added 3. So 1 was the oldest at the first time. Okay, then we did a get operation, so 1 came to for top, then the 3, so in the bottom right now it is 2. Okay, so the moment you add 4 to it, 2 will be removed. Okay, we will check that also. Again we will use s out, and similar things I'll copy it from here. So we will print this. See, I'll just do for second key. Okay, first let me write it down for whole, then I'll run it and I'll show it to you. Okay, so we have added 2, we have added 4, so 2 will be removed. Now what we'll do, we will add 5, and then that will remove the 3. Okay, because 3 is now last, so we will add now 5. Okay, this is 5 data. Okay, so I'll just write it down also for you. This will remove third key. Okay, and I'll show you by getting the data also. We will be getting null. Okay, for sure. So I'll just say for third key. Okay, plus dot get 3. Okay, now let's just run this and I'll show to you. See, For one key, this is the one data. For second key, it came null. For third key, it came null. Okay, because 4 and 5 have overridden my 2 and 5 key. Okay, so this is how we can make the LRU cache implementation. Okay, by using the linked hash map collection. I hope you guys would have understood it. Okay, if you still have any questions, put it in the comment. I'll go through it and I will reply over there. Okay, thank you all. Bye bye.